lines, coordinate plane, and all that. The reason why it comes back into geometry is because within geometry, we're still dealing with slopes, we're still dealing with points, we're still dealing with parallels, perpendiculars, and how we write the equations and how things are all interrelated and such like that. But one of the things that we have to go back to is, how do you work with the coordinate plane? When I say coordinate plane, I mean the x, y graph stuff. How do you work with finding slopes? How do you write the equations of lines? How do you write the equations of lines that are parallel? How do you write the equations of lines that are perpendicular? It's basically the stuff that you spent 3 weeks or so on back in Algebra 1 that will knock it out in about 3 days. Okay? Because it's all review, we hope. So we talk about this thing called slope. We're looking at this idea of things called slope. Do you remember, how did you find the slope of a line? Rise over run, very good. So we defined it as rise over run. Now, in an XY graph, what numbers rise? What numbers go up and down? The Y values, good. What numbers then, by process of elimination, go left and right? So one of the ways that we've written this before, we would say the change in Y over the change in X. You guys ever seen it written like that? The triangle? That triangle stands for delta. In Greek alphabet, the delta, it stands for change. Okay? So it's basically saying the change in Y over the change in X. And when you did slopes, how many points did you have to have to determine the slope? I can speak. Just 2. All you needed to have is figure out the slope between 2 points is literally the 2 points. So, yeah.
So what was the thing when you did like x squared minus x
Well, gee, I wonder if that's what I'm not right. It's okay. You're right though, because what would happen is, in order to find a slope, you'd have to have a set of ordered pairs. You'd have to have a set of ordered pairs. And when we have a set of ordered pairs, you've got your first set of values of x's and y's, and your second set of values of x's and y's. And that's where that subscript of x sub 1, y sub 1 come into play. We just label them. And just like she was saying, this idea of slope, the idea of slope became the change in y divided by the change in x. Now, what letter did they use to show slope? Do you guys remember the variable they used? What letter did they use for slope? Nope. M. Oh, it had nothing to do with that. Y equals mx plus b. So that's slope intercept formula. We'll talk about that later. So, do you guys know why they use the letter M? Okay. As you go through the alphabet, what are A, B, and C used for? Tag right there. I didn't hear you. Be louder. What's D used for? Distance, diameter. E is an exponential. F, G, and H are all used for function notations. F of x, G of x, and so on and so on. I is what? I is an imaginary number. Oh yeah, there's a whole set of numbers you guys don't even know about yet. J and K, they use a thing called direct and joint variations. And those are the constants of variation that they use for that. L is used for line. It looks like a 1 sometimes too, so I use that. They got down to M, and they haven't used it yet. Well, okay, we'll use this M for slope. I'm telling you, math people try to find the easiest way out anything. Seriously. Okay. So, and it also works that the fact that I just made all that up and you kind of believed it. But technically, the reason they use M is because it comes from the Greek word modulus. Modulus of things that change. You believe it, though. So if I'm talking about slopes, do you guys remember that there are 4 types of slope? 4 types of slopes. Remember which ones they are? What they are? There are 4 types of slopes. Well, we're dealing with lines since they're all going to be linear. What was that? I agree. There's a positive slope. So I was going to say, if there's a positive slope, that means there has to be a negative slope. Okay. Positive, there's negative. Oops. The other one. What is neither positive nor negative? Nope. Was it? No. What number represents what
0.
number? There could be a 0 slope. So you have a positive slope, a negative slope, and a 0 slope. And then the last one is an vertical. You're right. Vertical is undefined. So you have 4 possible slopes. Positives. You guys remember what direction lines went that had a positive slope?
Right and up.
Right and up. I was waiting for you to say and up. What happens here is if you're looking at positive slope, in an XY coordinate plane, if you go up and you go right, those are both positive directions. So it's positive, positive, negative, positive, negative, negative, positive, negative. Those are for your XY values. Are we okay with that?
Yes.
So as you're going up and right, it's positive divided by positive, which therefore is positive. If I'm going down and left, that's a negative divided by a negative, which is also positive. That's why up and right is the same thing as down and left. What? What do you mean? No. What's negative divided by negative? Right, so that wouldn't be a negative slope, would it? No, the reason why we say that is because sometimes when you're graphing things, like on your graphic, you might run out of space going in one direction. So that way you walk going the other direction. Because remember, the lines go infinitely in 2 directions, so you just have to figure out which way might fit on your grid. That's why we say that. Then the idea then of negative, so we say up and right. Or down and left means the same thing. Negative then would be down and right or up and left. Those are the same thing. When you're dealing with slopes, if you guys remember this when you did your graphs and stuff, I don't think we'll get to graphing today. We'll probably just wait to do some graphs tomorrow. When you're doing your slopes, remember your first step on a graph is to always go up or down, and then generally always go to the right. So if you went up and right, that means you had a positive. If you went down and then right, you had a negative slope. What kind of lines, don't say straight, have a slope of 0? Very good. Horizontal lines have a slope of 0. The reason why they have a slope of 0 is they're horizontal lines. The reason that they have a slope of 0 is because when you have a horizontal line, your y value never changes. So your y value doesn't change, so you get 0 divided by some value of x. That's why it's 0. Because 0 divided by something is always 0. Also, another thing to remember, what's the second letter in the word horizontal? Which looks like a 0. The equation of every single horizontal line is always the same. It's always y equals some number. Y equals 3. Y equals -7. Whatever. Y equals some number is always a horizontal line. And it tells you what that number goes through, and the slope is always 0. And then the last one then is the undefined. If horizontal was 0, vertical is undefined. And the reason why that it's undefined is that what never changes on a vertical line? The x value. The x value never changes, so it's a vertical line. So it's always some value of y divided by 0. You can't divide by 0. That's why it's undefined. And the equation of every single vertical line is the same. It's always x equals some number. So that stuff never, ever changes. I don't know. But it was either you add them to 180 or you outside equals the sum of the two. I should know that. I got you. So slopes, you will run the tally here. Changing y over the change in x. Find the slope between those 2 points. Find the slope between those 2 points, please. Remember, a lot of times when you're doing these things, especially right off the first couple of them, do yourself a favor and just label what points for which. You'll be less likely to mess up in the long run. What I mean is, just as you write down the problem, just write down, oh, that's my first x, first y, second x, second y. And if you forgot what the equation of slope is, write it out a couple of times, and you'll commit it to memory. Go figure. Between the 2 points, yeah, and we'll get to graphing stuff. Like I said, I don't think we'll get to the graphing today. We'll probably just be writing equations and things today. We'll worry about that later. But yeah, I would always say take your first step up or down and then move to the right. So let's see here. We had 2 minus a -6, 7 minus 4. Here's the best thing about having a multi-degree calculator. You should never get any of these things wrong. You can create a fraction bar and type everything in. And you won't be wrong. It'll simplify the fraction for you automatically. If I do this, I get 8 over 3. That's my slope. There are no mixed numbers. I think I've made mention of that before. Mixed numbers are awful. You can't walk slopes of 2 2/3. But I can walk a slope of 8 over 3. Yes, sir. 2 minus a -6. You have a calculator in your hand. You shouldn't get it wrong. Gotcha. Don't forget as you're reading these things, guys. Should not be same thing. As you write them through, just get accustomed to writing it out. The more you write down what you're doing, the more you write down the actual equation, the better it'll be committed to memory, and the easier it'll be later on. Change y, change an x. Label them as you do it, put it in the calculator if you have to. Minus 3, negative 11, minus negative 8. Let's see if we get 1, negative 3. Now, do you guys know what to do when you have a negative just in the denominator, not in the numerator? You know what it does? What do you mean by flip it? What do you mean? No, I'm just saying, right now it says 1 over negative 3. No, that would be that would just be flip it. I see where you're going with this. Now, if you were thinking about this in terms of a slope, let's just say you started at 0 and you wanted to walk that slope. What would your first step be to do? Go up 1, because the 1 is positive, so I go up 1, and then what direction? And left. Up 1, left 3. So up and left is the exact same thing as, and that's where I think you were getting at. This is the same thing as saying negative 1 over 3. Whenever you have a fraction, when you're talking about slopes, it does not matter, actually it doesn't matter for any of them, where the negative symbol goes. Traditionally, they'll float that negative to the numerator. So in textbooks, more often than not, you're going to see it written as negative 1 over 3, or sometimes they might write negative 1 over 3. All three of those mean the same thing. I believe if you threw that in the calculator, it probably just spit out as negative 1 over 3. That's fine. If you're cranking it out by hand, you would have done it the way I did, and then realize, okay, up and left is the same thing as down and right. That's why the idea is showing you guys that they mean the same. The directions are the same. Not terrible? After you guys worked with slopes for a bunch of times then you started talking about ways to write a linear equation. You started talking about different ways to write linear equations. And traditionally, you guys were taught one way first. What was this called? Very good. Y equals mx plus b is the most common form of writing the equation of a line because it's written as what's called slope-intercept. Where m is your slope and b is your which intercept? The x-intercept or the y-intercept? Y-intercept, very good. It's the y-intercept. Do you know the reason why that's the y-intercept, not the x-intercept? When you graph something, we'll come back to this one here real quick. And obviously, you guys don't have any graph paper, so it's not a big deal. You don't have to worry about it. I just wanted to show you what's happening. If you graph something, as you graph something, what is the value of y when the line crosses, or what is the value, so what is the value of x, I forgot what it's called, when you cross the y-axis? When it crosses, as I'm following this line here, as it crosses the y-axis right here, what's the value of x? When it crosses the y-axis, what's the value of x? Do you guys know which one's the x and y-axis? Okay, so this is your x-axis, and this is your y-axis. When it crosses the x-axis, what's the value of, excuse me, when it crosses the y-axis, what's the value of x? What's this right here? 0. When it crosses the y-axis, what's the value of x? What's this number here? 0. When it crosses the y-axis, what's the value of x? What's this number? When it crosses the y-axis, what's the value of x? 0. I couldn't hear you. You have to be louder. The value of x is 0 when you cross the y-axis. If you substitute in 0 for x and multiply it by anything, what's anything times 0? 0. That's why those ordered pairs work. So if I had 0 for x here, my y-intercept is at y equals b, whatever that b value is. That's why you were able to, when you guys graph things, if it was y equals 2x minus 3, you would start at -3 and walk your slope. That's why that worked, because the value of x is 0 when you cross the y-axis. On the other hand, when you cross the x-axis, what's your value of y? When you cross the x-axis, what's the value of y? 0. Same thing. Your x and y intercepts are when the opposite value is 0. Your x-intercept is when y equals 0, and your y-intercept is when x equals 0. Those are things you kind of need to remember because in Algebra 2, you use them a lot. There's a lot of graphing. There's a lot of linear equations in Algebra 2. A ton. So this might be a good section to make sure you guys really do well through. Okay. So, excuse me. Slope-intercept form. I think one of the first things you guys first learned how to do was if you were given a slope of 2/3 and a y-intercept of 3, what would your equation be? Right. This is telling you what your slope is and what your b value is, your y-intercept. If you know what the formula is, y equals mx plus b. If you know what this is, you substitute in. If you know what this is, you substitute in. And you go on your merry way. The weirdness came in when you had a slope and a point. You had to do a little bit more work. If you had a slope and a point, and you had to write the equation of the line for that. So, what's that? Yes, and there are two ways of going about doing this. The way that you're saying and another way. I'm going to show the other way first because that's kind of the more standard way of thinking. It's a little bit easier, especially for later on when we do parallels and perpendiculars. So when you have to write the equation of a line that has a slope and a given point, remember, you could do what she was saying, is you can go use the x's and y's, find the y-intercept. But the more traditional way is to use what's called point slope. It's called point slope form. The point slope form here allows you to substitute in values to get your equation into slope intercept form with two basic steps. Now, in this equation, this point slope form, there are 5 separate parts. Y, y sub 1, slope, x, x sub 1. You know 3 of them. The subscript values are the ordered pairs that you're given. Just like before. Those are your x and y values. Your x sub 1, your y sub 1. And then obviously your slope is also given. So what you do is you substitute in. Y minus 4 is -2 times x minus a -3. And anytime we see minus and negative, what do we automatically change it to? Always change it to a plus. So and now I have to get y by itself. In order to do that, I have to first distribute the -2. Now this is where most of you guys will make a silly mistake. Whenever you have distributive property, you're going to want to draw your arrows. And know where you forget to send it to the second term. And then lastly, how do you get rid of the -4? You get y equals -2x minus 2. That's the equation of the line that has the slope of -2 and contains the point -3, 4. Yes, ma'am. Okay, I know where you're getting at when we graph things. That is, put your pencils out for a second. You guys you're absolutely right. It's just substitution. You're just using direct substitution for plotting. So, what you guys have learned in the past is you created a table.
Yeah.
You picked values of you pick like -1 or sorry, -2, -1, 0, 1, and 2. You substitute in and figure everything out. Well, now since you know how to graph things, and like I said, we'll do more graphing tomorrow. Now that you know how to graph things, what's your y-intercept? -2. So I started my y-intercept at -2, and I put a dot. What's my slope? -2. So do I go up first or down first? How many do I go down? Then where do I go? Over 1. Good. Down 2, over 1. What's the opposite of down and right? That's all you have to do nowadays. You don't have to make tables. Because once you learn how to graph from slope-intercept form, your table time, the time for making tables, it's irrelevant. You probably won't make tables with any of the graph stuff again until maybe a couple when you get to quadratics or some polynomial stuff, cubic things like that in Algebra 2. You'll start with some tables till you start learning how certain things work. Same thing with exponential, logarithmic graphs. All those things you'll have to learn how to work with numbers like that as well. A lot of math ahead of you guys. A lot of math ahead of you. But yeah, so yeah, you don't have to worry about tables in a sense. But was that what you were asking about?
Yeah.
All right. Oops. Take a second. Write the equation of the line in a slope-intercept form that contains that point with that slope. There are 2 of them, please. Take a second and give them a shot. Do one other set of examples real quick, just kind of go through here. So there's your x and your y. When you're doing this type again, write out point slope form. It'll help commit it to memory. That helps. What's y minus 0 going to be? So what would it be? Distribute to both parts, you get 2x minus 6. Not too terrible. Same thing on the other side. You got your x and your y values. First x, first y, slope. Fill in the blanks. What do you got? Y minus 4 is your slope, 1/2 x minus 2. Distribute through, you just get 1/2 x, and what's half of 2? 1. So you get y minus 4, 1/2 x minus 1, and how do I move the 4? Add that 4 over. You got that. Again, what we're looking at here, guys, is it's a lot of substitutions and some solving for y. So it's the slope intercept. Y equals mx plus b. Point slope. So yes, sir. You want to get y by itself for these. Yes. We're not solving for x on these. The equation of a line is y equals something because it's a linear thing, so there's going to be 2 variables as opposed to the singular dimension solve for x problems. Here you've got 2 parts. You're just getting y by itself to get the traditional sense of what the line looks like. You're graphing it, you're basically getting the 2-dimensional. You have to have 2 variables. It's not just solve for x. Completely different. Completely different. The other form that you guys have seen before is when you have write the equation of a line that goes through 2 points. Okay. So, for example, let's say you have the ordered pairs. I want to write the equation of the line that contains those 2 points. And whenever I say write the equation of a line, I'm going to write the equation of a line into slope-intercept form. I'm always going to go to slope-intercept. One of the reasons why we always go to slope-intercept is because eventually, when we have graphing calculators, there's a button out there that says y equals. When you have that button that says y equals, you can do a whole bunch of other things out of the calculator, out of the graph. Later on, you'll learn how to figure out intercepts and all that kind of fun stuff. So when you have the 2 points, what's the one thing you can figure out from 2 points? The slope. That's what you have to find first. First thing you gotta do is find the slope. What's that? First thing you gotta do when you have 2 points is find the slope. So write out the equation for slope. Change in y over the change in x. Fill in the blanks. We get 2 minus 1 over -5 minus -2. And what is that? -1/3, I believe. So what do you guys got? So you get -1/3 for your slope. So second thing you'll do is use point slope and solve for y. So now you have your slope at negative 1/3, and then you have points. Does it matter which point you choose? Nope. You can pick either one. It does not matter. You're going to get the same equation with either point. Now, sometimes one number might be easier to work with the other. Sometimes, like in this case, unfortunately, when we multiply by 1/3, we're going to get a fraction in there, but it's not a big deal. You got a calculator. So I'm just going to use this first set of ordered pairs, negative 2 and 1. So the second step, use point slope form and fill in the blanks. So we have y minus 1 is our slope, negative 1/3. X, what's minus and negative going to be? Minus and negative 2? Yeah. So minus and negative 2 becomes a plus 2. Distribute out your negative 1/3. You have negative 1/3 x minus 2/3. And then what do you do to both sides for 1? Yeah, you just add the 1 over. And like I said, do not worry about the whole idea of a fraction. Put it in the calculator, press enter, you get plus 1/3. Gotta use the fraction part. You don't move out of it. But try this one for yourselves here. Really short here. Oops. Take a second. Try that. Write the equation in the line that contains those 2 points. Into slope intercept form, just like we did. All of our slopes aren't going to be negative 1/3. Now, there's one number that is going to be a little bit easier, or one ordered pair will be a little bit easier to work with than the other in this case. Which one? Yeah, negative 5 and 0 because there's a 0. Okay, it's a little bit quicker to work with. Either way, I mean, it will work either way, it's just a little less math. Y minus 0. So you wind up with y equals negative 1/3 x, and then, excuse me, negative 1/3 times 5, you throw out the calculator, you got negative 5/3. You're done. Now, when we go to graph things and work with that, we try to stay away from intercepts of fractions, just because they're awful to try to plot correctly, because it's never as clean as you'd like it to be. Yes, sir. Either one, you pick either one of those ordered pairs. Either one is fine. It doesn't matter. Either one of them will work. It just so happens that when you have one that has a 0 in it, well, you don't have to do anything with it, because it's y minus 0 is just y. What I want you guys to try tonight, it's in the books on 194, 13 through 15, and then I want you to do the 24, 32 evens. So the set of problems is you've got a couple of finding slopes, and then you've got a couple of each style of write the equation of the line, the slope intercept. You've got a point and a slope, 2 points, or a slope and an intercept. So it's examples that match everything we just did here in class, ladies and gentlemen. It should not be all that bad. We hope.